Hey everyone, welcome to this explainer. Today, I'm going to teach you a foundational skill that literally separates the rookies from the true networking masters. You know, in my 30 years working with Cisco gear, I've seen so many engineers just completely freeze up when the pressure is on. Well, today we are fixing that. I'm going to show you how to perform instant IP analysis in your head in a split second. No calculators, no apps, just your brain and the pure logic of classful IPv4 networks. Let's dive right in. Let's kick things off with a specific challenge, and we'll unravel the answer step by step together. We've got an IP address, 10.4.5.99, with a subnet mask of 255.255.255.0. Here is the big question. How you instantly find the network ID, the broadcast address, and the exact host count using just your mind. Keep this IP locked in your head because it's going to be our North Star for this entire breakdown. Now, you might be wondering, why do this in my head? I have a subnet calculator on my phone. Well, picture this. It's 2 a.m., you're freezing in a server room. The entire network is down, alarms are going off, and the company is bleeding money by the second. When you're staring at racks of routing gear and typing frantically into the Cisco CLI under that kind of intense pressure, you absolutely do not have time to pull out your phone. Knowing this theory instinctively, that is how you survive in the job market. This isn't just academic, it's frontline troubleshooting. Okay, everything starts with the very first number, the first octet. The whole IPv4 system is divided into different classes, and that first octet instantly gives away the IP's class. You need to memorize these ranges like your own name for your daily playbook. If the first octet is between 1 and 126, we're looking at a massive Class A network. If it's 128 to 191, that's a medium Class B. And from 192 to 223, that's a smaller Class C network. This is literally the first thing your brain should process when you see an IP. But listen closely, because you've got to watch out for the exceptions. You probably noticed some gaps in those ranges. Pay attention, because these exceptions will absolutely show up on your Cisco exams and in the real world. The number 0 is completely reserved for special broadcasting requirements. You can't assign it. And that entire 127 block, that's strictly reserved for internal loopback testing. You know, like the famous 127.0.0.1 you use to test your own network card. Don't let these trap you. So let's look back at our challenge IP, 10.4.5.99. We just look at that first number, the 10. When we compare it to the ranges we just learned, 10 falls squarely right into that 1 to 126 bucket. Immediately, alarm bells should be ringing in your head. Boom! This is a Class A network. Just like that, we've solved the very first piece of the puzzle. Now, knowing the network class instantly gives us the default subnet mask and the address structure. Because our IP is in Class A, its default mask is 255.0.0.0. So what does that actually mean? Well, that 255 essentially locks in the first octet as the network portion. And those zeros, they tell us that the next 3 octets are completely dedicated to our hosts or clients. So 1 part for the network, 3 parts for the hosts. All right, so across those 3 host sections, exactly how many devices can we connect? To find the exact number of usable hosts per network, we use this absolutely crucial golden mathematical formula, 2 to the power of h minus 2. The h just stands for the total number of host bits. Since each octet has 8 bits and we have 3 host octets in Class A, our h is 24. 2 to the power of 24 is a ridiculously large number, over 16.7 million. But wait, why do we subtract 2? This is a vital point to remember. Out of those millions of addresses, 2 of them are completely unusable for devices. We subtract 2 because the very lowest address is always reserved for the network ID. It's kind of like the name of a street. You can't actually build a house on it. And the very highest address? That's reserved for the broadcast address, which is used when a router needs to shout out a message to every single device on that network at the exact same time. Okay, let's break down this mental algorithm step by step so you can find these boundaries in your head without ever touching a calculator. It's a super simple 3-step process. Step 1, identify the class using the first octet. Step 2, to find the absolute lowest point of the network ID, just change all the host portions to 0. And step 3, to find the highest point, the broadcast address, change those exact same host portions to 255. Simple as that. Let's apply this beautifully simple logic to our challenge IP, 10.4.5.99. Based on our Class A discovery, we slice the address right after the 10. That 10 is our network portion, so it is locked in. The next 3 numbers, 4, 5, and 99, are our host portion, which means they are completely flexible. We are going to play with these last three numbers to define our exact boundaries. But hold on a second. Let's be real here. Knowing this math is completely useless in the field if you don't know how to execute it on a Cisco router. In the job market, nobody pays you for mental math. They pay you to pass traffic. You have to be able to translate this theory into an active configuration on the actual hardware. These are the mandatory Cisco iOS commands you are going to type thousands of times in your career. In global configuration mode, you first enter the interface, like interface gigabit Ethernet 0/0. Then you type IP address followed by your IP and mask. And finally, and I can't stress this enough, I've seen so many folks forget this over the last 30 years, you absolutely must type no shutdown. Cisco router interfaces are disabled by default for security, so this command physically wakes the port up. Once you've got that configured, your absolute best friend for verifying everything is the Show IP Interface Brief command. I literally type this in my sleep. It gives you a clean one-line summary of all your interfaces. What you want to see in the output is both the interface status and protocol showing up. In the networking world, we call this up and up, meaning your physical cable is good and your data link protocol is working perfectly. All right, let's piece our main master's challenge together and execute the mental algorithm. We lock in the 10. To find the network ID, we make the host 0, landing us at 10.0.0.0. To find the broadcast, we make the host 255, giving us 1025, 255, 255. And the usable hosts? 2 to the power of 24 minus 2 gives us a staggering 16,777,214 usable IPs in the single block. Boom. Challenge solved entirely in our heads. But wait, did you catch that little twist from the very beginning? We just proved that the default mask for a Class A network like 10 should be 255.0.0.0. But the original mask I gave you in a challenge was 255.255.255.0. It completely contradicts the default. Instead of one 255, the network has 3. So what exactly is going on here? This contradiction reveals something huge. The network has been subnetted. This means a network engineer actually borrowed bits from the host portion to chop that massive 16 million IP block into smaller, more manageable networks. This borrowing technique completely rewrites the boundaries we just calculated, changing everything about where the network starts and ends, which brings us to the ultimate question. Now that you've mastered classful networks, are you ready to dive into the dark art of subnetting in our next explainer? Keep that curiosity fired up because that's exactly where we're heading next. Thanks for watching.